So we're going to try a new unit, and as I said in the notes prior to this on the Google Classroom, that what you're going to need for this lesson is a roll of Scotch tape. If you don't have it, well, just follow along with this, but I think it's just more fun to actually do it. So I'm going to walk you through a demonstration. At a couple of points during the demonstration, I'm going to tell you to stop the video, to take some observations, see what you see, and then I'll show you what it should look like. It should work, but let's see. So, got a roll of Scotch tape here. Let me grab the camera so you can see what it is that I'm going to be doing. So, with my Scotch tape, here we go. What you're going to see here is that I'm going to take just a length of Scotch tape. It's about like the length of my finger here. All right. Hang that off the side of the table. Right, so what I'm going to do here is I'm going to put the tape down on my table, right, so a little bit is sticking off the edge. I'm going to take a marker. You can do a pencil, a pen, it doesn't matter. And actually, it might work better with a black pen, so let's do that. Okay. There we go, black pen, and I'm going to put the letter A on that piece of tape. Then I'm going to take my Scotch tape, again, my roll of Scotch tape, which is hard to do while you're holding the camera, so I'm going to put that down. That's the same size as the first piece of Scotch tape, and I'm going to put that somewhere next to it. Same thing, just a little bit of Scotch tape sticking out over the edge of the table. I'm going to mark that with a B, and let's see if I can do this one-handed now. I'm going to take another piece of Scotch tape, put it down, same length as the other one, right on the table. I'm going to mark that with a C. And then finally, another length of Scotch tape. I should have probably prepped this ahead of time. And there you go. Here's the difference. Ready? I'm not going to put it down on the table. I'm going to put this piece of Scotch tape on top of piece of tape C, right? So I put it on top of. Now watch what I do here. I'm going to want to separate pieces C and D later. So I'm going to kind of like fold piece D back on itself. It's not going to stick to itself because the sticky side is down, so just fold that back. I'm going to write a D on that. Let me smooth that out. Oh, D. Okay, great. So we have our pieces, our 4 pieces of Scotch tape. So what are we going to do with them? Here we go. Let me set the camera up so you can see what I'm doing. Here we go. And so what I'm going to do is take piece of tape A, and I'm going to rip it off the table. Oh, apparently took part of the table with it, right? Take piece of tape B, pull it off the table, and then I'm going to bring them close to each other. So you should stop the video and then make an observation. All right, so you can start again. Hopefully what you're seeing is the following, that when I bring them close to each other, they push away from each other, right? They repel from each other, which is sort of really weird, okay? There you go, right? They're trying to get away from each other. So I'm going to put these 2 on the side, all right? Next what I'm going to do is I'm going to take a piece of tape C, which is the one that's on the table, rip that off, and now, so I have C like that, C and D, and I'm going to rip them apart, and bring them, oh my God, they attract each other, which is sort of weird. So what I want you to do now is compare what C and D do to all of the rest of the pieces of tape. So if you want to stop the video, you can also redo the whole demonstration if you wanted to see how A, B, C, and D react to each other. You can prepare them in exactly the same way. So let you stop the video, and then we'll figure out what happens and record some observations. All right, so let's see what you got. I'm going to set this up here so we can take some notes based on what we saw. So first off, you should have figured out what this unit is all about, right? Because you've probably seen something like this before. And if what you're thinking about is the concept of static electricity, you are right. This is exactly what we're talking about here. But we're not going to call this static electricity because that terminology makes no sense. Because the word static means to not move, and the word electricity is about moving stuff. And so it doesn't make any sense to call it static electricity. The correct term for this concept is something known as electrostatics. And that's what we're looking at, electrostatics. And so let's just write down what we thought we saw there. So I had a couple of pieces of tape. I had A and B. I had C and D. But we could also compare A to C, A to D, B to C, as well as B to D. That's all my combinations. And so hopefully this is what we saw. What we saw was A and B repelled each other. C and D attracted each other. Now when you did the rest of them, what did you see here? Hopefully you saw that A and C repelled, A and D attracted, B and C repelled, and B and D attracted. Okay? Or A, B, and C, we just like think of them as a group, these all repelled each other. And then D over here on the side, right? Anything from this group was attracted to anything from that group. But anything within this group all repelled each other. So what is all of this about? Well, if you know what this is about, you will have learned in the past that electrostatics, or this concept of static electricity as it's normally called, is really the study of charges and their interactions. And that's what we're going to be looking at here. So when I say charges, what sort of charges am I talking about? Well, charge comes in a couple of different flavors. And I love that word, the flavors of charge. It's actually the appropriate scientific word to use, believe it or not, right? The flavors of charge here are positive, negative, and neutral. And so the question is, well, what charges were these? Were these positive, negative, or neutral? So hopefully you've learned in some other earlier grade some basic understanding of the interactions between charges. So what are those basic interactions? Hopefully what you just said was that like charges repel and that opposite charges attract. Okay? Like charges repel, opposite charges attract. Basic idea there. Hopefully you also saw during the demonstration that the closer the charged objects were, the stronger the force of attraction or repulsion was, right? And that's going to be a basic notion as well about this chapter, or this idea. Now, here's the thing about this. So the question becomes then, well, what's positive, what's negative, right? Well, if I look at this as well, being positive or negative is not a normal state, right? It's not like all these things were attracting or repelling until I did something. So think about that as well. Like the tape in and of itself is not going to attract or repel anything, but because of the way that we prepared the tapes, we attracted or repelled. So stop the video here. Think about what's positive, what's negative. All right, so hopefully what you said was that A, B, and C all had the same flavor of charge, and that D was the opposite flavor of charge, right? So if A, B, and C, you said were positive, that made sense that they all repelled each other, and that D was negative. Or A, B, and C was all negative, and that D was positive, right? But the question is, which is which? Well, based on this demonstration, there's actually no way to know if A, B, and C were positive or negative. All I know is that they were prepared in exactly the same way, right? These were all on the table, so it made sense that they would all end up as the same flavor of charge when prepared. But D was not on the table, it was on C. So it was prepared in a different way, and therefore should end up with a different type of charge or flavor of charge. But the question is, we still don't know what is what. What's positive versus what's negative? Well, how would I know what's positive and what's negative? All right, so hopefully you had a chance to think about that. Believe it or not, there's actually no good way to know this. At some point in time, someone had to just make a decision. Does anyone know a famous scientist, a famous American scientist who just made the decision for us about what was positive and what was negative? Nope. All right. Well, hopefully you thought of our friend Benjamin Franklin. Ben Franklin in the mid-1700s actually does an experiment that was kind of similar to what we did here about comparing objects. So what he noticed was there was a whole bunch of objects that when you rub them together started displaying this weird attracting and repulsion tendency. And so what sort of materials did he play with? Well, he played with things like wool, and he played with things like fur, and with things like rubber. I have a balloon here. Think about other times when you experience this. Taking off a wool sweater sometimes, or if you put on workout clothes, that synthetic material when it goes over your hair, or rubbing your shoes, certain types of shoes on certain types of carpets give you this effect. And so what Benjamin Franklin did was he took all the materials that displayed this effect and noticed that some of the materials attracted each other and some of the materials repelled each other. And he made two groupings, right? Sort of familiar from what we did. All the objects in this grouping, just for now, we'll call it grouping A. Everything in A repelled all other in A. And then he had another grouping in B and said everything in B repelled all other in B. But anything from A would attract anything from B. And so that's how we kind of got these rules. And he's like, oh, okay, well, I have two flavors of things. When I have like things, they repel. And when I take one from each grouping, they attract. And so all he did was he took one object from each of those groupings to kind of like become the prototype for that, right? The stand-in for that. And he wanted to name those groupings something. And so he just called one of the groupings positive and the other groupings negative. His rationale there was saying, sometime in history, someone is going to be able to put some numbers to this. I don't know enough to put any numbers to this, so therefore I can just have someone else do some numbers to this, but we'll put it in the language of mathematics, so eventually it'll all make sense. And so, well, what did he choose from the positive and negative? Well, What he chose as negative was if you take a rubber rod and rub it with fur. Now he used specifically cat fur. Cats were everywhere in Philadelphia. I was about to say ancient Philadelphia, in colonial Philadelphia, so very common there. Rubber rod and rub it with cat fur. He said that the rubber rod was negative. Why? Because someone had to decide it at some point, and the rubber rod strongly displayed an effect. So he's like, okay, I'll make the rubber rod negative. And the next, for positive, he took a glass rod and rubbed it with silk. And then he said the glass rod was positive. And so therefore, he had his standards of charge, the rubber rod being negative, the glass rod being positive. Now, in this interaction, it's important to note as well, and this will become important for our next lesson, right? When the rubber rod became negative, the cat fur became positive. And when you rub the glass rod on the silk, even though the glass became positive, the silk became negative. And we'll talk about why that's true in terms of what's going on the next time. But now I can figure out what's positive and what's negative because I have my standards for what's positive and what's negative. So if I take my piece of tape then, and I use a glass rod or a rubber rod, I'm going to be able to tell whether each of these pieces of tape were positive and negative. So I'm going to do that for you in another video, but I just wanted to get you a start along the lines of what we're talking about with charges. We have positive charges and negative charges. We'll dive a little bit deeper into what's going on in our next discussion.